So today we're going to look at a new subject in math called integration. So integration. So in simple terms, integration is just the opposite of differentiation. And integration is represented by a simple term in a simple way. So this is the integral logo, and then you have f of x dx. And what does this mean? This basically means the integral of f with respect to x. So what does it mean? It basically means you're integrating with respect to x. Now, before we proceed, we must understand a few rules. So the first rule is that if you have two functions, let's say f of x and g of x. So this is the first rule. If you have f of x and g of x, and you want to find the integration of the sum of f of x and g of x, which is the integration or the integral of the sum of f of x plus g of x, don't forget the dx, all you have to do is just multiply the terms. Multiply the terms with d of x and find the integrals individually and add them up. So what does that mean? So all I have to do is take the integral of f of x. Remember, don't forget your dx. Your dx must always come in each one of these. Plus integral of g of x dx. Alright? Now, what does this mean? So if I give you this, you quite don't understand. So let's assume a basic example. Okay. So let's say f of x is x cubed and g of x is, let's say, x squared. So let's find the integration of these two terms. We're not going to solve it. We're just going to show a mathematical representation of what this could be. So integration, or the integral of f of x plus g of x dx, correct, is now equal to integral of, what is f of x? X cubed. Substitute g of x, x squared dx, and then just integrate them individually, which is integral, again, x cubed, don't forget the d of x, okay, plus integral of x squared dx. This should be your representation at the very least, the most important thing. Now supposing we have a constant multiplied to this. Supposing we have a constant multiplied to f of x. So let's say the constant is any value, a real number, a constant which is a set of real numbers. So let's say the value k. Okay, k is a real number, and you have the integral of k times f of x dx. Now what do? This is interesting because you don't have to integrate this. The k, there's nothing to do with the k, it's a constant. Just like in differentiation, you can pull that out. So you write k, take it out, and bring the integral forward. So integral of f of x dx. And all you have to do is integrate it and then multiply. So like we did before, let's assume again f of x is equal to, let's say, x cubed, as the same, just the same example as we did before, taking that. And let's say k is now equal to a real number, which is 5. So now, I won't be solving the value, I'm just showing you the representation, so don't panic. So let's do this. So let's just substitute for whatever, for the same function as this, which I've highlighted. So integral of 5, and what is f of x? X cubed dx, correct? Now because 5 is a constant value, or a constant real value, a real number, we can bring this out. We don't have to involve it with the integration. So all you have to do is remove it out, integral x cubed dx. Very, very simple. Not too complicated, very simple. Okay? So these are some of the simplest terms that I would like you to understand before we move on to anything. All right? So now, this is something interesting. So supposing we have all this done, now let's look exactly as to how to integrate. So I'm going to remove this entire thing. Give me a second. Okay. Let's just remove this as well. Okay. Integration. So what I recommend is, whenever you're doing a sum, always keep a formula sheet, just like here. So this formula sheet with you at all times. You can download this online. There are tons of images, and you can download this, or just rip the paper of your textbook and keep this formula sheet. It helps a lot. So the basic of the basic integral. So let's start with the first one, as we see here. Okay, integral of x of n dx. Correct? So I have to integrate x raised to the power n, the function x raised to the power n, with respect to x. Simple. That was the definition of what the integration is. So as you can see, it's very simple. If you can follow it, it's x raised to the power n plus 1 divided by n plus 1. Pretty easy. Just add 1 to the power, and take the whole power and put it in the denominator. I think that's pretty simple. So let's do an example like before, as we did. Let's say integral of x cubed dx. Correct? So how would you do this? You would simply say, you would add 1 to the power, correct? Follow this. Simple. Follow the formula as here. Simple. Or just follow the formula as it is, or you can just imagine adding 1 to x cubed. So not 1 to x cubed, adding 1 to 3 to the power 3, sorry. So 3 plus 1, okay, so that's the change we made, divided by, again, 3 plus 1. So the red is basically what we've added. As you can see, you can compare the two sides, so you can compare these two sides. This and this kind of remains the same. All we've done is we've added 1, and we've added and we've placed 3 plus 1 in the denominator. So what does this become? X raised to the power 4 divided by 4. As simple as that. Now, if you understood the previous two properties that I explained, which will be commonly used, let's do something a bit trickier with this. Supposing I give you a question, integral of 6x cubed dx. How would you solve this? How would you solve this? You can pause and take your time. Don't take a lot of time, but if it doesn't come intuitive to you, it should simply be, because 6 is a constant value, 6 is a constant value or a real number, all we have to do is bring it out. As simple as that. So 6 times the integral of x cubed dx, which is simply 6 times, okay, you can just put a bracket if you're not feeling comfortable, 6 times x raised to power 3 plus 1 divided by 3 plus 1, which is equal to 6 times x raised to power 4 divided by 4. Now if you want to reduce it down to the smallest value, it would be if you divide by 2 in the numerator and denominator, or cancelling if you're familiar with that. So this is 3 and this is 2. So it would be 3 by 2 times x raised to the power 4. Correct? How simple was that? Correct? Now let's see an interesting case where the power is -1. Okay? So let's do that again. So integral of x raised to the power -1 dx. Never forget the dx. So let's apply. So how do we do this? We add 1 to the numerator, as we all know. X minus 1 plus 1 divided by -1 plus 1. Well, this is interesting. The denominator is 0. Correct? The denominator sums up to be, so it's x raised to power divided by 0. Correct? So what do you see in this case? So when n is equal to -1, n is equal to -1, right? The integral of x of n dx goes to infinity. Correct? So this formula, as stated above, the formula is only true if n is not equal to -1. This is very important, and we'll see why. Because if you remember, if you look at the formula sheet and you look down here, you can see there's an integral for x raised to the power -1. X raised to the power -1 is the same as 1 over x, for all those asking, and it just becomes the log of x. Just remember this. So remember, this is a very important case. Now that we've understood this, let's look at the exercise questions. And I'll be solving for exercise 7.1 in the Cbse NCERT book. So let's look at this. Okay, so exercise 7.1. Let's do all one question at a time. Sorry about that. Let's see. Let's start with it. Okay. So let's start with that. Let's start with the first 5 questions. So the first 5 questions is basically asking you to find the derivative or the integral by method of inspection. Okay, so method of inspection. So we have to understand what is method of inspection, okay? So this is quite tricky and it's quite interesting. So basically, if you know about integration right now, integration is basically the opposite of differentiation. You can see even in the formula sheet, you can see differential of sine x is cos x, but the integral of cos x becomes sine x. And the differential of minus cos x becomes sine x. So the integral of sine x becomes minus cos x. So you can see they flip, correct? So what we want to do is, so let's take an example. So let's do the first one, the first question. Okay, so let's see how we can do this by method of inspection. So sine 2x. Now you might be thinking, well, I don't see sine 2x in the formula, but I do see sine x. If you thought of that, the integral of sine x is minus cos x right here. That's very good. You've come to a part of its solving. You've come closer to solving the question. So now what do we do? Now we look at something particularly interesting. We look at the differential just left of it over here. So if we want the differential, if we want sine x, we must differentiate cos x, correct? If I'm not mistaken, I think that's how it works, right? So let's do this. So let's differentiate cos 2x. Okay? So let's differentiate cos 2x in order to get sine 2x. Now, differential with respect to x, cos 2x, cos 2x is equal to what? It's very simple. So it is minus sine 2x. Now, because you know that because you differentiate with respect to x and you differentiate cos to sine, but you have 2x, so you have to differentiate 2x also, because over here the formula is only cos x. So you need to differentiate 2x and multiply with that. So the differential of 2x is what? 2. So the whole thing times 2. Interesting, correct? So what is, now let's try to isolate the sine of 2x, which is equal to minus half, I'm sorry, no, wrong, this is wrong, sorry, minus 2 times sine 2x, correct? If I take this to the other side, what happens? It becomes d by dx, correct? Minus 1 by 2 cos 2x. Now you might be asking, why did we take minus to the other side? Will it affect? Well, if you differentiate this, remember this, sorry, just will finish this, sine 2x, sorry. Whenever you have this, the half comes out, so it doesn't matter. So we just directly went to the solution and we just said, okay, it's inside. So minus half cos 2x. Now this is interesting. Now let's compare this to this. Okay, so let's compare this thing to the formula. So the formula is d of dx minus cos x is equal to sine x. I think we all know this, correct? So what's interesting is if I differentiate cos x minus cos x, I get sine x. And if I integrate sine x, I get minus cos x, if I'm not mistaken, as shown here, correct? If I integrate sine x dx, I get minus cos x plus c. Oh, by the way, an important thing to remember is whenever I integrate, you must put the plus c. This is another rule which I forgot to mention. I must have not done it in the previous questions, but just remember that plus c is very important. Correct? So this is dx. My apologies. Correct? So what does this mean? Now, if you compare this, the representation is kind of the same. So basically, the integration, so if you, let's go back here again. So the integral of sine x gives you minus cos x, which is basically over here, as you can see. Correct? So therefore, the integral using this, what we've seen here, like as we've seen here, what using this representation, let's do it for the same. So the integral of sine 2x dx must be equal to exactly, sorry, minus half cos 2x. So now you see how we've done something, found the antiderivative or the integral of sine 2x using the inspection method, just by using the inspection method. Correct? So this is how you do using the inspection method. The simplest thing, now if you're a bit confused, here's what I'm going to tell you. Okay, simplest thing. Okay, if you're confused by all this is just an explanation. If you want, watch back and come back again. I'm sorry, again I forgot this, plus c over here. I'm really sorry. Watch this again, but I'm going to show you an easy way to do this. Okay, so that you can memorize this and it'll be very easy for you. So let's do this very simply, very simple. I'll give you the rules as to how to do this, or the algorithm as to how to always solve questions like this. Okay, so when they say solve using the inspection method, 1 minute. Okay. And okay. So again, let's using the inspection method, you're going to come across 3 types of integration. One is sine, cosine. Okay, and it doesn't matter. So for example, you will get sine 2x or sine 3x, correct? Or cos 2x, cos 112x. Now when you see this and you get petrified, you get scared and you think, oh, should I know some integration based formula in order to solve this? No, don't be worried. Simply do this. Okay, take the differential. Okay, take now sine and cosine. Whenever you differentiate sine, you get a cosine, negative, positive. Don't worry about that. It always converts to a cosine, kind of like complements. They're complementary to each other, right? So a cosine, if you differentiate cosine, you will get a sine, correct? Even if you integrate a sine, you get a cosine. If you integrate a cosine, you get a sine. So the easiest way is, the first thing you do is take the, if it is a sine, take the cosine of its value. So if it is sine 2x, take the cosine of it, cosine 2x, and just differentiate it. sorry, d by dx. Okay, which is, what is the differential of cosine? Minus sine, right? Minus sine 2x. Now you have to differentiate whatever is inside. Whatever is inside. So what is here? Differentiate and multiply. So differential of 2x is 2. So this gives me minus 2 sine 2x. All I have to do now is isolate sine of 2x and take 2 to the other side. Okay, so now d by dx minus half cos 2x is equal to sine 2x. And this becomes your integral value. This is the integral value. Correct? So therefore, the integral of sine 2x dx, correct, is equal to minus half cos 2x plus c. Don't forget the plus c always. Okay, it's as simple as that. Get it? Okay, so you think, so let's do another example of the same, because now you've seen this, so I've done this already. So let's repeat the same algorithm for, 1 minute. Let's remove this. Let's do cos 112x. We might as well do it. Okay, so cos, so you want to find the integral of cos 112x. Now change to its complement, which is sine. So sine 112x, correct? And find its derivative. What is its derivative? Simple. What is the derivative of sine? Cosine. Cos 112x. Take the differential of the inside of the angle value basically, times 112. Correct? Which is equal to 112 times cosine 112x. Now you want to find the integral of this, isolate, take 112 to the other side, which is d by dx 1 by 112, sorry, sine 112x is equal to cos 112x. Correct? So what is the integral? This becomes the integral, and it is denoted by f of x. So if this is f, let's not confuse with these terms, but let's assume you know that. So basically, you can actually prove it, that the integral is this. So if I integrate on both sides, integral this and integral this, correct? What happens? This 2 gets cancelled, right? This 2 cancels each other out. This and this cancels each other out because they're the opposite of each other. If I integrate something and I differentiate, I go back to the same equation. Correct? Correct? Exactly. Only the thing is, I have to add plus c over here. That's it. If I'm integrating, I get that. That's it. So this becomes my integral value. Now, this is for sine and cosine. Now, what about something like, I would say, let's see, so let's say question 3 in exercise 7.1, which is e raised to the power 2x. So e raised to the power 2x. Very interesting e raised to the power 2x is. So how do we do this? Now I know that the now e to the power x, the differential of e to the power x is e to the power x. Therefore, so let's write that down. So differential of e to the power x is equal to e to the power x. Therefore, the integral, I can go backwards, which is my integration, correct, of e to the power x dx is equal to e to the power x plus c, correct? Exactly. So it's very simple to do this. So now, regardless of what happens of e to the power, regardless of what it is, and a lot of people get scared when they see this and they think, oh, there is 2 now. Now, in this question, it's e raised to the power 2x, but the formula is e raised to the power x. And you might get worried and say, what do I do now? How do I do this by method of inspection? Well, don't worry. Don't be paranoid about that. They're interchangeable. Whether you integrate or differentiate, it remains the same. Correct? So you don't have to worry. All you have to do is a very simple thing is take e raised to the power 2x and differentiate it. Correct? And what is the differential? E raised to the power 2x. Now, because it's 2x over here, again, you have to differentiate this value, e raised to, you have to differentiate 2x. So differential of 2x is 2. So multiply by 2, which gives you e raised to the power 2x. 2 times e raised to the power 2x. And again, as before, isolate e raised to the power 2x, which is d by dx, half of e raised to the power 2x, correct? Which is equal to e raised to the power 2x. Now you can integrate on both sides, which results in e raised to the power 2x dx is equal to half of e raised to the power 2x. So as you can see, this becomes the value of integration. Simple. So it doesn't matter. And if you see a common pattern with this, what happens? It just goes to the denominator, whatever the end value is. So if this is 2 over here, if this is 2 over here, 2 over here, for example, e raised to the power 2x, if it's e raised to the power 112x dx, all I have to do is 1 divided by 112 e raised to the power 112x. Very simple. So 2 cases have been done. So you have sine, cosine, e raised to the power n times x. So what is the final one? Let's look at that. What if you have something with a power? Correct? Something with a power. So this is the simplest of them all. What if you have something like x cubed? Let's say, I would say something like, let's get a better example. I would say, what would be a good example for this? Let's say 4x cubed. That's a good example. Now this is pretty simple, right? You know that so now you know this is easy. You can just do it in your mind and you can do this in your head. But what about by the method of inspection? That is something that's kind of tricky, right? Like, how do I go through the method of inspection? Well, if I integrate something, doesn't the power rise by 1? Correct? So the simplest thing to do, doesn't it rise by 1? Correct? The simplest thing to do is that I just reduce it by a power of 1. So what I'll do is, is this a good example? Let me think. Yep. The power is increased. Yep. So if I integrate something, I'm sorry, I was just a bit confused there. Sorry. If I integrate x to the power n, all you have to do is increase the power by 1 and divide it by n plus 1. Very simple. As long as n is not equal to minus 1. We know this rule is very simple. Now, if that's the case, how would I get cubed if I integrate something? Correct? So that would be something like, how would I get cubed? You would need x squared, right? So if I integrate x squared, I would get x cubed to the power 3. But what about by, I'm sorry, I've made a mistake. I'm not figuring out where did I make a mistake. Oh yeah, we're doing method of inspection. I'm sorry. So what do we have to do is very simple. Very simple. Don't worry about the constant. Yes, I'm sorry, I'm in a bit of a haze. So don't worry about the constant. Only worry about the exponent value. Correct? So let's do this. So x cubed. Instead of x cubed, take x to the power 4. Increase this by 1, the power by 1, and differentiate it. D by dx. Correct? Which is equal to what? 4x cubed. Correct? So do you see something interesting? So by the method of inspection, we've actually found it. So I just thought of it as to how would the differential happen? Correct? So in order to get x cubed from a differential, I would need x to the power 4. Correct? And if I differentiate x to the power 4, I get 4x cubed. And remember, whatever is after the d by dx, now this is only for the method of inspection. I don't want you thinking that this is going to be the whole questionnaire like that. This is only for the method of inspection. If they ask you through the method of inspection, you only do this. All you have to do is increase, don't worry about the constant or the real number, worry about this and reduce this by, and increase it by 1, I'm sorry, increase the exponential power by 1 to x raised to the power 4 and then differentiate it. Correct? And that will give you, and then differentiate it. Correct? Which will basically give you this equation, which will basically give you to this, and this becomes your integral value plus c. Correct? So integral of 4x cubed dx is equal to x raised to the power 4 plus c. Same as we did before. Correct? So let's generalize everything. So if you have an exponent e raised to the power n times x, what do? You first you just write it this way, differentiate e to the power nx, okay, and then differentiate e to the power nx, which will result in being equal to, what will it be equal to? E raised to the power nx times n. Correct? And all you have to do is take n to the other side, which will result in take n to the other side, which will result in d by dx 1 by n e raised to the power nx is equal to e raised to the power nx. Correct? So for any value of n, whatever the power is, so if it is e raised to the power 2x, 3x, 4x, whatever, it just follows this. And for sine and cosine is pretty simple, as discussed before. So this is the method of inspection. Now in the next video, we will go through the remaining questions. Now the remaining questions do not go through the method of inspection. Although there is one important question I've just missed out, which is a good thing I saw, is ax plus b, the fourth question. Wow, this is interesting. Now this is quite tricky. Okay, let's do this. Now this is quite tricky. The fourth one is a very tricky one. This particularly is good. So now ax plus b the whole square. Now you knew three. You knew one with cosine and sine how to do it. You know one with e raised to the power x. So which one does this fall into? This falls into what we did previously with 4x cubed. Again, just follow the method. It's only these three cases is going to happen for the method of inspection. Okay, so what do? You follow the same algorithm, increase the power by 1. So all you have to do is increase this power by 1 and then differentiate it. So let's do that. D by dx ax plus b. Now increase the power by 1. So 2 plus 1, which is basically, 3. Okay, so let's differentiate this. Now how do you differentiate this? Simple. Now you differentiate the whole thing, which is 3 times ax plus b, and then you have to differentiate what is inside. Don't forget that you have to differentiate inside. Correct? So times, now how do you differentiate inside? You can differentiate them individually. What is differential of a times x? Remember, a is a constant. A is a constant. A is a constant. So how do you differentiate this? A comes out, correct? And x becomes 1, so we don't have to worry that. B is also constant, so that becomes 0. So x becomes 1, times 1, and b becomes 0 because they are constants. Correct? So which is equal to, now a times 1 is a plus 0 is a. So it is 3a times ax plus b. So therefore, now all I have to do is, this is square. See, my bad guys. See, I forgot to do this. This is a mistake on my side. I'm sorry, I forgot to put the 2 here, ax square. Correct? Now we need to isolate ax plus b square, so we take 3a to the other side, which is d by dx. Okay, times 1 by 3a ax plus b cubed. Correct? Sorry about this. Is equal to ax plus b the whole square. So what does this mean? Therefore, the integral of ax plus b the whole square dx, remember, don't forget the dx, a lot of people forget that, is equal to 1 by 3a ax plus b the whole cubed plus c. Like I said, this becomes the integral solution. this one. This becomes the integral solution of ax plus b the whole square. All right, I hope that's clear. So now we will go through the next set of questions, that is question 6 to question 21. No, question 6 to question 22, yes, in the next video. Now hopefully this was helpful. If you found this video helpful, or you have things that I might have missed out or could have possibly mistaken, you can comment them, you can ask questions. Hopefully I'll have time to respond to those. And most importantly, like, share, subscribe, and click the bell notification so that you receive any updates, any videos I put out is going to come first to you. And let me know, what would you like next? Would you like something of another chapter? Would you like me to proceed on to the next exercise? Would you like a detailed explanation? Comment them all below. Thank you for your time and hope you have a great day.